Okay, we're going to solve number 7 from the review sheet here, which tells us that we've got a rectangle that's 5 feet by 8 feet in dimensions. So I'm going to draw that here. It's 5 feet this way and 8 feet this way. And then it tells us we're going to cut corners out of each corner. So cutting corners out here, square corners. I'm doing the best I can to draw them, obviously. So each corner is represented by an X. All of these little guys are X's. Now it wants us to maximize the volume of this, and that's the easiest thing to do. Only one equation needs to be developed, and we do that very simply. Say volume equals, well, we know it's length times width times height in any sort of rectangular prism type shape that a box is. And so the length is going this way, but the length only runs from here to here, which tells us the length is 8 minus 2x, because we have to take the 2x's out of the corner. The width only goes from here to here, which is then 5 minus 2x. Well, then we have the height part of it as well, which is by this x dimension, which goes here. So our volume is simply, once we multiply all this together, a nice little expression that is 4x cubed minus 26x squared plus 40x. Okay? Well, obviously, since we're maximizing the volume, we need to take the derivative of it. So v prime in this case is equal to 12x squared minus 52x plus 40. And then we're taking the derivative, setting it equal to 0, and factoring. Well, the first thing I want to do is take out the GCF of 4. And that just makes it easier to factor. 3x squared minus 13x plus 10. And that's easily factored into 3x minus 10 and x minus 1, which gives us the factors. X equals 10/3 and x equals 1. Now if you took this 10/3 and plugged it back up, say here, you'll actually get a negative number, which we know is not possible as far as dimensions go. So we just simply reject this one. And this will be the basis of our dimension. However, we do have to maximize it, so we're testing it on the number line again. So we say 0 here, we put the 1 on the number line, and we see if a value between 1 and 0 would be positive. Well, if I put 1/2 in here, I get a negative, and I get a negative here, then negative times a negative is a positive. Okay? And then if I take a number larger, then I will actually get a negative, meaning that this is, of course, the maximum that you're looking for. Now did the problem request anything other than this dimensions? No, it just wanted the dimension by the square. So that would all we really need to write then is our x value of 1 foot for the answer. And that's it. And we're done.